thing you might be asked to do this week is solve for zeros in an equation that might not look like it's in quadratic form, but it kind of really is. And we're going to do a substitution process for this. The first one we're going to take a look at is going to look like this. This one here, you could FOIL it out and expand it and then find the zeros. However, if you do the substitution process, it's actually quite a bit easier. Now, when you're finding zeros, you're finding basically where you cross the x-axis. So for something like that, we're going to have the f of x here be 0. So we're technically doing 0 equals 3 times 1 minus x squared plus 5 times 1 minus x plus 2. Now, in these, rather than trying to simplify and not make a mistake doing that, it would be better to just do a substitution and turn this into an easier quadratic to solve. So on this one here, what you want to do, and actually on all of these, is look for something that if you square it, you get something else within the actual problem. So if you take a look at this one here, if you look at this, right here we have that squared. So that's going to be our clue as to what we're going to substitute. And you can pick any letter as long as that letter's not in the actual problem. I'm going to go ahead and just use P. So we're going to let P equal the 1 minus x. That means P squared is going to be 1 minus x squared. So this right here can become a p squared. So we have 3p squared. And this right here can become a p. So we have 5p. And then we have plus 2. And this all equals 0. Now it's a normal quadratic that we can actually solve using quadratic formula, factoring, whatever you would like. I'm going to go ahead and just use quadratic formula. And if you remember, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, because p is the letter we've put in there, this is what p will equal. When we get to the end and we find our p, we're going to have to substitute back because really what we want to find is x, not p, in this problem. But first, let's find p. So our a is 3, our b is 5, and our c is 2. So when we plug into the quadratic formula, we find that p equals the opposite of 5 plus or minus the square root of 5 squared minus 4 times the a, which is 3, times the c, which is 2, all over 2 times a, which is 3. Now, we need to simplify this, and we have to follow order of operations. So the place we're going to start is underneath the radical with the 5 squared, which is 25. And then 4 times 3 is 12, and 12 times 2 is 24. So this is 25 minus 24. And that ends up being 1. So we have square root of 1 here. Out front, we have a negative 5, and on the bottom, 2 times 3 is 6. So then square root of 1 is just 1. So we have negative 5 plus or minus 1 over 6. At this point, we can actually separate this into two problems, one for the plus and one for the minus. So we have negative 5 plus 1 over 6, and we have negative 5 minus 1 over 6. On the first one, negative 5 plus 1 is negative 4 over 6, which reduces to negative 2/3. Always reduce if you can. On the second one, negative 5 minus 1 is negative 6 over 6, which becomes negative 1. So those are the two values for p. We found p, we did not find x, but this problem needs us to find x. So we're going to go back up and substitute each of these values into this equation here so we can find out what x is. So now remember, these are both p values. So for the first one, the negative 2/3, that's going to be this p, and that's going to equal 1 minus x. For the second one, the negative 1, that's going to be your p, and that's going to equal 1 minus x. If we solve these, we get our x, which would be our 0 for the original function. So now let's go ahead and solve for x in each of these. So on the first one here, I'm going to subtract 1 from both sides. And that gives me negative 2/3 minus 1. And 1 is the same thing as 3 over 3. We need common denominators here. So I'm going to go ahead and multiply the top and bottom of this by 3 to get that. And that's going to equal negative x over here. Once I have my common denominators, this becomes negative 5/3, which equals negative x. And then if you multiply the whole thing by negative 1, we find that x is 5/3. That's our first 0, which would be an x-intercept of 5/3 0. On the second one, if I subtract 1 from both sides, I get negative 2 equals negative x. Then let's multiply everything by negative 1 to get a positive x. So we get 2 equals x. So our second 0 would be 2, which would be the x-intercept of 2, 0. Now that one was one where we could see real clear what our thing was that was being squared because we had parentheses around it, and so you could see it. Sometimes it's not quite as easy to see. So you might and oh, actually, also, just to verify, let's go back up. If you take a look at the graph of that original one here, notice we have 2, 0 as an intersection of the x-axis, which would be the first 0. And this here is the same thing as 5/3. If you took 5 divided by 3, it would round to that, and that's your second 0. So on a graph, you can verify that what we got algebraically was actually correct. Now, let's go ahead and take a look at another one. This one's not quite as obvious. This one here, if you take a look at it, nothing jumps out at you. It's saying that if you square this, you get something else. But if you take a look at this, and you let it be p, we'll use p again. Watch what happens if you square both sides of this equation here. If I square both sides, this side over here becomes p squared, and the square and the square root are opposite functions, so we get an x over here. So notice that we do have an x in this function, and that x can actually become p squared. And then your p can become that square root of x. What that makes for us is it makes it so that we have g of x, which is going to be replaced by 0 since we're finding a 0. And our g of x is going to become, let me switch off of here back to a pencil, 0 because we're finding zeros. This x we just showed here was p squared, and this square root of x is going to be p. And that gives you a much, much easier thing to solve. So this we can go ahead and factor, probably. Factors, we have a positive 1 out here. Factors of negative 2 that add up to the 1 right here would be 2 and negative 1. 2 times negative 1 is negative 2. And 2 plus negative 1 is the 1 in front of the p. So this will factor into p plus 2 times p minus 1. Now, since we factored it and we have two factors equal to 0, we can set each equal to 0. So p plus 2 equals 0, and p minus 1 equals 0. To solve the first one, we are going to go ahead and subtract 2 from both sides. So p equals negative 2. The second one will add 1 to both sides. So p equals 1. And now we have p's, but the problem had x's in it. So what you have to do at this time is substitute back in. Now remember, the p is square root of x. So we need to replace the p in each of these with square root of x. Now the first one, notice we have a square root equaling a negative. That is never going to happen. So this is an extraneous solution, and we can just cross it out and not use it. The second one, however, we can go ahead and finish. And the way we're going to finish this one is if we go ahead and square both sides. And the square root of x squared, the square and the square root cancels, we get an x, and 1 squared is 1. So that means the 0, or the place where this graph should cross the x-axis, is at 1, 0. So let's go ahead and take a look at the graph of this, and you'll see that that's exactly where we cross the x-axis. So the graph verifies what we found algebraically.